All right, so I want to do a couple things today. I want to show you how to set up. I want to do one, show you. Ooh, drugs. That's nice. I want to show you how to set the problem up so it works, because it took me a long time to figure this out. And then I also want to show you the importance of using the appropriate soil models. Okay, so let's talk first about how to set the problem up. So we're again doing we're only doing half the problem using a symmetry about the left-hand side over here. And then we've set up. There's two ways to put structural elements in here, which are either tiebacks or beams or whatever, any kind of a structural element. One is to do a structural interface. Okay, and a structural interface, what it does is it puts two sets of nodes next to each other so that you can insert a structural element kind of like in an envelope inside another boundary. So this is appropriate like when you want to do a sheet pile wall where things where things can slide across each other. So this is appropriate for our sheet pile wall. So what we're essentially going to do is put in an envelope and then insert the sheet pile inside the envelope, and we can control the boundary conditions on either side of the envelope. So let me go back and remove some of this stuff. I'll leave those ones in because those ones are simple. Well, I'll delete those too. Go back to scratch. Okay, so we've created our basic space that we want to put our piles, that we want to put our sheet pile in. We think we've made it big enough, but we're not sure. And the first thing we're going to do is create the sheet pile itself. Now to install the sheet pile, we're going to use a structural interface element. So the structural interface element, what it does is it puts your structural element you're going to stick in, and it puts an interface between that element and the soil elements, so that the soil can slide across the interface and stuff. So we're going to add a structural element. When you do that, you have these following options: both ends open, both ends closed, first end open, second end open. And if you want to think about that, that's whether the nodes on the element are fixed to the nodes on the interface. And so what we want to do is we want to fix the node at the bottom of the pile. So that one's going to be fixed and attached to the soil, so that's not going to slip. But the one on the top, we want to allow it to move so that the soil can move up and down the pile if it needs to. Is that clear? So what we're going to do is we're going to use our first end open and second end closed, which means we have to remember to draw from the top to the bottom, right? Does that make sense? All right, so we're going to do that, and we're going to install a pile. We know where it's going. It's going at 20, and it's going to go down 30, 35, is that what we said? This is... I think that's what we said. No, it's going down 40, right? Is that what we said? Does anybody remember? 50? Okay, 50. So it's going to be 20 comma minus 50. All right. So that's our, so we've now installed this, and I installed it at the wrong time. So let me move it over to 2, and I'm going to install at stage 2. So that's installed at stage 2. And now we're going to check out its properties. So if you look over here, in the center you have the, when they say liner in here, they mean some structural element. A liner is just a structural element. It's got that name because this was set up originally for rock support, and the rock support is usually in terms of a liner. So when you see liner, just think of structural element. So there's a structural element that goes in the center, and on each side there's a joint which defines the joint property. So the first thing well, let's do the joints first. So you can define a bunch of different joints if you want, but if we look at joint 1 here, so here's the interface that we can use. There's a bunch of different models for this. We're just going to use a more Coulomb interface. And the question is, does it have any tensile strength? Does it have any cohesion? Or is it just frictional? Now this is frictional. We've got a, should talk about my soil. I'll talk about that in a minute. So we want to put an interface friction angle here. This is soil against steel, so it should be significantly less than our friction angle for our soil. Look at 33 degrees for the soil. We'll talk about the soil in a minute. And so this has got to be less than that, so I put in 20 degrees there. And I also put in a really low stiffness for the normal to shear strength so that the interface isn't interfering much with the transfer of stress. So that's my interface. Does that make sense? I want to really, in fact, this is fine. So so if you want to think of it, that's like a numerical sleeve around the sheet pile that controls the properties about how the sheet pile interfaces with the soil. Okay. So, and I've got the same one on both sides. You can put it, if you've got a different material on the other side, you can use a different one, but I've defined a joint. They define these as joints because this is the same way the same terminology they use for a rock joint. If you have a rock joint, it's the same thing. You put in the properties of the rock joint. Now in the middle, you want to put in whatever your liner element. In this case, we're going to put in a sheet pile. Now we got to think about our sheet pile and how we're going to model it. And so I'm using, hope this is right. So I went to the Metal page because it had a really nice set of, it has a nice table of data. And if we look at, remember the sheet pile is continuous. So the sheet piles are relatively easy to model in this because the sheet piles are continuous and we're modeling an infinitely long continuous thing here. So all I need to do is to go in here and pull out the moment of inertia of the pile and the cross-sectional area of the pile and put those in the model here, and it will calculate, and it'll be able to calculate the stiffness and the bending in the pile. Be careful that you use the units right. Now these are in areas of square feet, so I've converted, this happens to be for an AZ12 770, which is down here. So I'm using this sheet pile right here. I actually haven't checked to see if this is adequate, but it's just the one I put in. And I've converted the area to, this is a little confusing. It's square feet per foot if you're doing if your units of measure are feet. And the moment of inertia here is it's really feet cubed per foot because it's per foot into the board. And you'll notice that your specifications for your sheet piles always come that way. Notice that their moment of inertia here is inches to the fourth per foot. Because that's the way you design your sheet piles, it's per foot width. So I've done that conversion. I'm going to put 29,000 KSF, 29 million PSI for our modulus, Poisson's ratio of 0.3, and we're good to go. And we're just going to model this as a beam. So that's our sheet pile. And so this element, if you want to think of it, actually consists of three pieces. It consists of the sheet pile in the middle, and on each side is an interface, and we put a frictional interface in there on each side. And we fix the end of it, and you see this double circle here versus the single circle at the bottom, or if you want to say the node at the top has a circle around, that indicates to you that the node at the top is an open node, and the node at the bottom is fixed. All right? And when we say fixed, it's fixed relative to the soil. So at this point, the soil and the sliding elements on the sides and the sheet pile in the middle are all tied together at that point. They're all going to move together at that one point. So I've got my sheet pile in. Now I need to define how we're going to excavate this thing. And I discovered that there's probably no reason to use the actual excavation tools in here. All you need to do is go to the level that you want to excavate and just insert a stage boundary. And we've already got these nodes here. So our first stage, we're going to excavate down 5 feet. So we're going to put one stage in there, and it will automatically remove the soil above it. It thinks it knows what it's doing. It does about half the time. And then after we, it took me a long time to figure out how to pre-stress the piles. But the way to pre-stress the struts is, as soon as you excavate, we're going to put a load on this node here, equal to the pre-stressing force that we want in there, and then we're going to drop then we're going to put the strut in, and then we're going to take the load off, and it'll transfer the load to the strut. I couldn't find a way to pre-stress the struts. I went on the thing and said pre-stressing the struts, and it never would pre-stress them, so I don't understand how that's working. But so what we're going to do is we're going to put a load on the pile. We're going to drop our strut in, and then we're going to take the load off, and of course that load's going to get transferred to the strut. Do you understand that? Yes, no? Maybe so. Completely understand it, obviously. Clear as day. No? All right, well, we're going to do it here, and we'll see what happens. So we're going to add a load. And this is really irritating and confusing. Oh, no, we got to mesh up first. I'm sorry. Let me finish this part. This is what drives me nuts. We got to go back to John. We got to before we can put loads, we have to have nodes to put the loads on. Before we can put the nodes in, we've got to draw the mesh. Before we draw the mesh, we have to have all of our boundaries put in. So we're gonna finish putting in the stage boundary. So our second stage of excavation goes down to 15 feet. So we're gonna put that one in. Whoops, I put that in the wrong place. That's okay. We're just going to come down to, let's see, level 1 load. Level 2, oh no, that's right, cool. Level 2 excavate, okay, cool. Level 2 install, level 3 load. Level 3 excavate, and then we're going to put in our boundary for our third one. And then level 4 excavate. We'll put in a boundary for our fourth one. There we go. Okay, cool. And then it's useful to go back and check that you have all these in the right place. So the first one we are going to allow the earth. You know, basically on the first one, we're going to install our elements. We're going to turn on gravity, and we're going to let gravity load the soil. In the second stage, we're going to install the facing element. You notice it comes in there in the second phase. In the third stage, we're going to excavate. In the fourth stage, we're going to put a stress on the. We're going to put a load on there, so I'm saving a load for that. In the fifth stage, we're going to add our supports. So now we can come to support. No, I got to be meshed up to do this, I think. Let me see. Support it. Yeah, I've got to be meshed up to do this. Okay, so now we're going to mesh up. Woohoo! All right. We're going to use quadrilaterals in this. Triangles don't work too well for continuum and stress. The quadrilaterals work a lot better. So we're going to use quadrilaterals. We're just going to, I just initially guess about how many nodes we're going to want. I'm going to discretize this. And if you notice here, in this area, let me go back to the early one, we're only getting 2 nodes in each section. That's not very good. But if I go here and put a lot more nodes on here, and then discretize, then I'm going to get a very dense mesh on here, which seems like a waste of computing time and money. So what I'm going to do is I'm going to go back to, there's several ways to do this. There's several ways to improve your mesh. So we're going to start with the coarser mesh. And then what we're going to do is we're going to refine the mesh. What we want to do is refine the mesh in the center point and then let it expand out at the edges so the cells get, so the the mesh gets coarser at the edges and stays fairly fine in the center where we're concerned about it. So there's several ways to do this. One way to do it is to create zones, to create additional zones within the mesh area. So I've created 2 zones. I've gone here in the middle and said, hey, I want this a lot finer. And so in this region, I've told it to do a finer mesh. And then out in the outer region, I said, I want you to grade this mesh so it gets coarser as I go out. So that one I put graded. And the only way you can do this is just play around with it. But if I discretize this now and then mesh it, this is an okay mesh. It's not a great mesh, but you notice that I've got a lot of elements in here, and it gets coarser as I build out. That's probably not a really good mesh. Another way we can enhance the mesh is we can come down here and we can pull down from this menu of places where you want to increase. You can either increase the density of the points at the edge of the mesh, or you can increase the element density. So we're going to try increasing the element density. And I want to increase the element density in this region here. And so that helps some, but that's not going to increase the number of nodes at the edge really. So that's one way to do it. But another way to do it is to, let's see, I want to go back to here, discretize and mesh, is to increase the discretization density. Now this is going to increase the density of the nodes around the outside. But I get some pretty funky nodes in there when I'm doing that. But we're going to try that and see if it works. So now I have my, I've got my, I've got to fix my boundary conditions now, right? So let's go to loads and restraints. Okay, the first thing I want to do is I want to remove all the boundaries on the top. And then on the edges, I want these ones to be vertical displacement only. There, that looks right. I'm not real happy with this meshing, but we'll see if it works. If it doesn't work, we'll come back and work on it some more. So now I have it meshed. And so now that I have it meshed, I can put on loads. So what we're going to do is, we got the equilibrium mode, we're going to install our facing, then we're going to excavate. And as soon as we excavate, I'm going to put a load here equal to my pre-stress load. And I've messed with this and have some idea of what I think it should be. So I'm going to put a 2-kip horizontal load. And you have to, this is a real pain in the butt. You have to click stage right here, and you have to edit the stages where you want that load to come in. If you don't do it here, you can't change it. You just have to delete it and put it back in again. So the first stage is the equilibrium stage. We don't want it there. We don't want it in the second stage. That's when the facing goes in. We want it on the third stage. That's where we're going to put this load on. And then the fourth stage is where we're going to drop the strut in. And then the fifth stage is where we're going to remove that force and essentially pre-stress the strut. So it's going to be on in the third phase, on in the fourth phase, and off in everything else. And we're going to put a 2-kip load. I'm going to apply that. And that is going to go right on this node right here. Right, so I have 2 kips there. So notice that here's the equilibrium, the facing goes in, I excavate, and as soon as, at the same time I'm excavating, I'm putting 2 kips horizontal load in there. Everybody with me? Now I'm going to put in my support. So now I can put my support in. Support, I'm going to put in a liner. Now I have already put in some standard pipe sizes. I'm going to show you later how to set the pipe sizes up. So that's going to go right here. So let's go back and review this. So I equilibrate my problem. I put the facing in. I wish it in place, or I install the facing. I'm going to excavate and put a 2-kip load on here. I'm going to install my facing, and then the next phase, I'm going to take the load away. So now that load should be in the strut. That clear? Do you understand how we're pre-stressing the element? And the way you do this physically is you drop the element in place and you jack it and you put wedges in. So we're essentially putting our jack in and then dropping our element in. Okay? Looking for some feedback.
Where was the staging for the load? There was that table where you
I'm going to put in one more in. Okay? Let's go to the next stage. So I'll do it again. So now we're going to go to the next stage. We're going to excavate. So now here's where we want to put our pre-stressing load in, right? So we're going to go to loads. Going to go to where they have the uniformly distributed loads. We're going to add a line load. Okay, and then on the line load, we want it to be staged. So you go to the stage loading, right there. Now in this case, so this is the second level, right? And so the first. We don't want it at the first stage. We don't want the second stage. We don't want a third and a fourth stage. We want this, and the fifth stage is where we remove the load. So the sixth stage is the excavation for, see down here, sixth stage is a level 2 excavation. That's when we want to put the load on. So we're going to put one in there. The seventh stage is where we're going to drop the strut in for that layer. So we're going to one in there, and then we're going to remove it for all the other ones. Yes? Okay. Okay. So we'll just put 2 kips in here too. So I'm going to put that right here. Okay, got a 2-kip load there. Now I'm going to go to the level where I'm going to install my support. So then we're going to go to support. We're going to install a liner. We're going to install the same 8-inch standard pipe. I'll show you later how you actually how you put the pipe in, because that's a little more complicated. How you define the properties for it. Okay, you with me? Jack, ask a question.
originally we were going to install the support like 2 feet above.
I know, I just got tired of doing that, so I put it here. You got to put more nodes and more stuff in, and it seemed like it was. You could do that. These things don't get installed all the way at the bottom of the excavation. They get installed a little bit above it, but it just seemed like a pain in the butt. I got rid of the water too, because that was too much to deal with at this time. All right. So now the next stage is removing we remove the force on the wall, so that's going to load the strut, right? And now we're going to excavate the next layer. Just going to excavate the next layer. We're going to put our load in. So we're going to go back. We are going to put in a line load. We'll leave it at 2 kips. Now I got to check the staging. In this case, I don't want it to be in 6 and 7. I want it to go in on 9, and it'll stay in for 10 when I drop the strut in, and then it'll drop off for 11 and 12. So that one's going to go right there. So there's another 2-kip load. We go to the next stage. We're going to install our support. We go to support. We're going to install our liner. We're going to install the same 8-inch pipe that we had before. That's going to go right there. And we now have built everything into our problem. The next stage is we're going to load the strut. The load comes off. Stage 12, we excavate, we're done. Now before you do anything else, you need to walk back and through and make sure you've got this all set up. And this is I find this really frustrating that you have to set part of the geometry up and then mesh it, and then you can put more of the stuff. It's really, I find that incredibly confusing, difficult, and a pain in the butt. But that's the way it seems to work. So the very first step, that's when we're just going to put the gravity loads on, and we're going to give it a step just for the gravity loads to be applied and all the stresses to be applied. Then we're going to put in our facing, that's step 2. Then we're going to excavate. At the same time we excavate, the 2-kip load comes on. Then our support gets installed. Then the 2-kip load goes away, so that's going to transfer that load to the strut. Then we excavate to the next level, and we put in our pre-stressing load there, 2 kips. Then we install our support. Then remove the 2 kips, it's going to transfer it to the strut. And then we go to the 3rd level, apply our pre-stressing, take it out. I'm sorry, put it in the strut, take off the load, transfer to the strut, and then we excavate down to the next level. Okay? Das ist gut, ja? All right, so then you definitely want to save. And now we're ready to compute. Before we compute, I don't understand this exactly because you set the mesh up, but you definitely want to come back here, and there's two mesh checking algorithms here. And one of them checks to make sure that you don't have any elements that are floating out in the middle area. It checks to see that the nodes are all connected. And for some reason, I mesh this thing up, and it does the meshing, and then I put loads and stuff on, and I get problems. So I check this all the time because it makes sure that that's good. And the other thing, this is not a great algorithm, but they have a little algorithm to check for bad elements. Bad elements are elements that are like really skinny and really flat, or turned inside out, or things like that. This won't show you all the bad elements. There's some elements here that aren't very good in this area, right? In whoops, cancel. I mean, you like elements that are nice and square. In here we've got some pretty funky shaped elements, but there's no elements that it thinks are really horrible. So now we can compute. It's really important that you watch the computations and make sure that it's converging, because it's not going to tell you. So right now it's having a hard time converging on this particular phase. In fact, you can see that it's not going to converge. And if you just happily run along and let this thing calculate, I got this to converge the other day, so I don't know what's going on. It'll finish the program, it'll plot stuff up, but the numbers don't mean anything because the problem hasn't converged. And so if it's not converging, it usually means you don't have a very good mesh. There's something wrong with your meshing. So I think we've already got one step that didn't converge. So this is up to, so that one didn't converge either. I'll show you how you know whether they converged or not. So don't just go happily along turning in results when the algorithm didn't converge. When it didn't converge, it means you don't know what's going on. The way you know that happens is you click on this and it says, you go to display your data, and it says, oh, by the way, we didn't converge in a couple things. Do you care? And your answer should always be, yes, I care. Take a look at the log file, figure out, well, it's not converging. Let's see. What stage didn't it converge on? All right, so stage 6, we didn't converge. So is that the only one? I guess it's just on stage 6. I thought on stage 3 there was a problem. So we got a problem in stage 6. So when we get to stage 6, our answers aren't going to be good anymore. But I want to go through this right now, and then we'll come back to it. So now we want to look at our answers. It's helpful to turn on the display of the. I like to turn on both the elements and the how do I pan? I know how to do this with the mouse. I don't know how to do it without it. Oh, I think I just do it this way. Nope.